So last time we looked at the electric field around point charges, and we were able to visit the electric force, the electric field strength, and the electric potential equations. This time we're going to be looking at uniform fields, and these primarily exist between two charged plates. In other words, this can be defined as a capacitor. Now we'll go into more detail in the topic of capacitance and capacitors in a later video. Today we're just going to be looking at the electric fields between two charged plates. So let's say I have two metal plates that are connected to this battery here. And you can see that this battery is charged to 400 volts. Well, this plate here is connected to the positive terminal of the battery. So this plate here is going to be charged to 400 volts. And this side here is connected to the negative side, and in this case the negative side is at 0 volts, so this here is charged to 0 volts. And because this is connected to the positive end, we can say that there are positive charges accumulated on this metal plate here, and we can see that negative charges have accumulated on the other metal plate. And we know that electric field lines point from positive charge to negative charge. So for two charged parallel plates, the electric field lines will look something like this. So you can see that these field lines are parallel to each other and are evenly spaced out, and at the ends of the plates you have two curved lines due to end effects. The electric field strength equation for two parallel plates is given by the equation E is equal to V over D, where V is your potential difference, and this is given in volts. And in the case above here, your potential difference here is just simply 400 volts. And D represents the distance or the separation between the plates. And that's given in meters. So your unit for your electric field strength can also be represented by volts per meter. Note, however, that this equation here is only for uniform fields. So you cannot apply this to cases where you have point charges. However, we did previously see that the electric field strength is also equal to the force over the charge. So if we were to equate these two equations, we could say that F over Q is equal to V over D. So the force between two plates is equal to the charge on one plate times by the voltage divided by the distance. Now instead of having one plate charged to 0 volts, let's say one plate was charged to 400 volts as before, and you have a second plate charged to 1000 volts. Well, in this case, the 400 volt plate is your negative plate and your 1000 volt plate is your positive plate. And that's because the 1000 volt plate has a greater voltage on it. And your PD from both of these plates is 600 volts. There are quite a few good questions on parallel plates, such as how an electron would pass through them and the path it would take. So if you could go away and find a question like that, that would be very useful. And we will go over these sorts of questions in the course that I have made. Now, the best piece of advice I can give you after watching that video is to go off and practice some past papers or topic questions. These are single-handedly the best way to help you commit the content you've learned to memory. Obviously, go and do all the YouTube stuff of liking, subscribing, and if you found this video helpful, feel free to go and watch any of my other ones.